got linquad4, and then today we got 4. Oh, did you guys like print out the worksheets? Or is it like you just look at it on the iPad?
Print out the notes, but I look at the work.
Because I have to revise tonight's homework. So I just tonight's one, I believe. You look. Yeah, just tonight's one. Basically, I removed one problem. So that's better for you, yeah? So if you printed it out, just cross out the last problem. It's a word problem. Okay, let's take today's basic schedule then. So who wrote that? Why is that all still up there? Is that you? Strike one! Anyway, if you're going to write all, you don't write it like that. You write it like this. All. See, because then it looks like 911. Do it. Help, 911. Call the mathematics ambulance. Help. Are you kidding me? Number 2. Okay, see. This is just telling me we have weakness in algebra. Okay, what does negative third power mean? 1 over 2 plus I to the third power. Okay, and then how do we expand? Do we know how to expand a plus b to the third power? Yes, because we went over Pascal's triangle. Okay, let me just review. This is the last time I'm writing it on the board. A plus b to the third is a to the third plus 3a squared b plus 3ab squared plus b cubed. Even in AB calculus, you gotta know this. Look, 1, 3, 3, 1. Okay, so this is A and this is B, so what's the A cubed? A cubed. This is A. A cubed, A, plus 3A squared B. So what is 3 times that squared times that? 12I plus 3ab squared. 3 times that, 6 times that squared, which is negative 1, minus 6. If you can, plus that cubed. What is I cubed? Minus I. So 1 over, now I don't care how you do it. Even if you're going to go 2 plus I times 2 plus I times 2 plus I like a barbarian, I don't care. You can do that if you want. But you better get here. Right? And then how do you simplify? What do you do? We talked about this yesterday. Multiply top and bottom by? Rhymes with conjugate. The conjugate. And so what do we got? 2 minus 11i all over 125. So that's equal to 2 over 125 minus 11 over 125i. Because when you work with complex numbers, you wanna write it in the form a plus bi, right? That's the standard form. Anyway, I was talking. You know what the practical applications of complex numbers are? Electrical engineering. In fact, I just saw a guy. He came back. I guess he graduated early from college, 3 years, and now he's going to Stanford getting his PhD in electrical engineering. And I said, oh, so electrical engineering, you guys still use a lot of logic and complex numbers? He said, yeah, that's all it is, man. Logic and complex numbers, because you use complex numbers to analyze alternating current, electricity. You guys know the difference between alternating current and direct current? What? Direct current is?
Direct.
It's like a battery. Whereas alternating current, that's the thing you plug into the wall here, right? Alternating current. That's where you get electricity from. Number. So now we're going from all to only 4 problems now. I thought you put all. We're not doing all. No, so how come there's only 4 problems? Oh, so then we all of a sudden became smart then.
It was 6 all. That's what it was supposed to be.
Oh, 6 all.
Yeah.
All of
Oh, and wait a minute, I don't see number 4 on the board. Everybody did number 4, because usually every single year that's a problem. But this year, no, we're smart. All the, so I walk around the room right now with my grade book, everybody did number 4. Okay, we'll get it. This is for 5 points. You get 0 or 5. So, then why isn't it on the board? Why isn't it on the board? Let me ask after. See, you're foolish if you don't write it on the board because you don't know how to do it. Then you copy it down in your homework, it's done. Right? You didn't have time to do homework last night? Copy it down. Now you can get 100%. Oh, now it's there. You guys don't know how to play the game yet? Obviously not. Okay, well, before we do number 4, then everybody did number 3 then. Because they kind of go, how do you show that 4 minus 3i is a square root of 7 minus 4i? Yeah, you square it, and then you get that, okay? So this is the same thing, except we're going backwards. It says find the square roots of 3 plus 4i. In other words, what complex number squared will give you 3 plus 4i? In fact, you know what? The probability of this being on tomorrow's quiz just went up. It went up from 0.1 to 0.8. The probability that this problem, except of course I'm going to change this, right? It's not really the same. What complex number squared will give you 3 plus 4i? And the answer will be the square root, right? Okay, so how do you solve a problem like this? Well, you just multiply this out. In fact, didn't I give you that hint? What? That's just shameless. Okay, multiply this out. A squared plus 2abi minus b squared is equal to 3 plus 4i. Did I do that correctly? Are you guys at the stage now, whenever you see I squared, you just do -1 already, right? In your head. Okay, now when you work with complex numbers, I believe I showed you this yesterday, but let's do it again. If a plus bi is equal to 7 plus 6i, what can you conclude? A is equal to? And b equals? Yeah, so same thing. Anytime you work with complex numbers, the real part on the left gotta equal to the real part on the right. The imaginary part on the left gotta equal to the imaginary part on the right. And then what do you see here? 2 equations, 2 variables. Okay, when you come out of Algebra 1, you're supposed to be experts at 2 equations, 2 variables. When you come out of Algebra 2, you should be experts at 3 equations, 3 variables. When you come out of this class, you can be experts at n equations, n variables. Don't worry, you will be. Okay, do you want me to do the algebra? Was that did you get to this step? Because if you write this down tomorrow, you get 1 out of 4 points, no questions asked. No, you gotta solve it, you gotta use algebra. Okay, what's the normal procedure for solving 2 equations, 2 variables? Solve for 1 variable in 1 equation and plug it into the other. That's called substitution, yeah? So which variable is easiest to solve for? What do you want to do? Solve for b in this equation. B equals 4 over 2a, which of course can, please simplify. You're going to learn that if you simplify your work, numbers get smaller, so you less chance of making errors. And then what do? Plug it into the other equation. So you get a squared minus 2 over a squared equals 3. Multiply out a squared minus 4 over a squared equals 3. Get rid of the fraction. Multiply through by a squared. So you get 8 to the 4th minus 4 equals 3a squared. Now this is not a quadratic equation, but it has quadratic form. You guys know what I'm talking about? You guys did plenty of these last year. Mr. Uba showed me. You know what I mean when it has quadratic form? This power is double that power, and that's a constant. It has quadratic form. So you can treat it like a quadratic. So factor it just like a quadratic. Except instead of going a and a, you put a squared and a squared. Except probably last year Mr. Rubash and Mr. Take used to taught you the u substitution. You know, u equals a squared. You know what I'm talking about? Come on, we're at a high level already. We don't need to. Just put a squared and a squared. It's easier. And then 4 and 1 minus plus. So a squared is equal to 4 or -1. How come I cross this one out? Because otherwise a is going to come out imaginary. You know when you have a complex number, a plus bi, a and b have to be real numbers. You know what I'm talking about? So that's why you cross out the -1. Therefore, a has to be, if a squared is 4, what is a? Plus or minus 2. Plus or minus 2. So, there's two answers then. If a, here, let's make a chart. A is plus or minus 2. If a is 2, how do you figure out what b is? Where should I go back? All of these equations, where do I go back to figure out b? Right here. b equals 2 over a. So, what is b? What is 2 over 2? What's 2 over -2? So, what are your two answers then? Your first answer is going to be 2 plus I, that's this thing, and the other answer is -2 minus I. So these are the square roots of 3 plus 4i. In other words, if you were to square both of these numbers, you would get that. So, could you repeat this problem tomorrow if I just change these two numbers here? Well, we'll find out, won't we? The probability just went up to 0.9. Did I tell you number 1 of tomorrow's quiz already? I did, right?
Oh, the triangle.
Yeah, I'm going to give you the 3 vertices of a triangle. You're either going to have to find the orthocenter or the circumcenter. That's number 1. I'm not going to ask you to find a centroid because that's too easy, right? There's a shortcut for that. If you cannot average 3 numbers, then just go home, right? Okay, so you know number 1, the probability of this one being on the tomorrow's quiz is 0.9, which means what? You better study it. Okay, next, number 6. Oh, we are not doing number 6 all. Are you kidding me? Okay, here, I'll tell you how to do it. 6a. Make one side 0. You cannot factor it. Use the quadratic formula. Right? That's just a basic use the quadratic formula. Okay, but what about b? Now, this is where I want to see what you guys are doing. Are you guys like doing the barbaric way, or are you like doing like the more efficient way? Like, how do you solve this? Multiply out the left side, make one side 0, and then factor it. Yeah, you can, but look, it's in a form that's screaming at you. How do you solve this? Square root both sides. Okay, so what's the square root of? Let's see if you remember anything from last chapter. What's the square root of something squared? No.
The
Absolute value of something. What's the square root of 121? 11 or plus or minus 11?
Plus minus.
No, it's 11. We didn't learn from last chapter.
I thought it was a trick question.
No, it's not a trick question. Therefore, 3x minus 2 is equal to plus or minus 11. This plus or minus comes from the absolute value. Remember I told you last time, because when teachers do this, they usually skip this step, and that's why students think this is that, and that's 2 mistakes right there. A plus or minus comes from the absolute value. Can you take it from there? I guess not. So 3x equals, add 2 plus or minus 11, and then divide by 3. So x equals 2 plus or minus 11 over 3, which can be simplified to, what's 2 plus 11? 13 over 3. Or, what's 2 minus 11? Negative 9 over 3 is negative 3. Those are your two answers. Of course, you can do it the other way, multiply this out and refactor, but come on, the thing is in factored form already. Okay, E. No, what problem is C? Oh, I think we should go over these. Because some of you are just befuddled, yeah? What does befuddled mean? Can I cancel x minus 1 from both sides?
No.
Yeah, well, yeah, you can, but then you're losing a solution, right? These are quadratic equations. There should be 2 answers. So if you cancel x minus 1 from both sides, you lose a solution. Therefore, you're going to lose half the points. However, you can cancel it from both sides if you remember what? What's the solution that you're losing by doing that? 1. So then you put that 1 as the answer. You know what I'm talking about? Because can you see that 1 is an answer? Because if you plug in 1, you get 0 equals 0, which is true, right? So yes, you can cancel it if you remember that you're losing it, so then you put it in. And then look how easy it is now. 4x equals negative 5, so x equals negative 5/4. There you get 2 answers. So no, you cannot cancel it, but you have to account for it. You know what I'm talking about? Otherwise, what? Okay, otherwise what? Mr. Perk, I don't know what you're saying. Then don't cancel it. Do this then. Make one side 0. That's always the normal procedure for solving quadratic equations. And then factor this side. How do you factor this side? multiply it all out and refactor. No, you got an x minus 1 here and here, so factor it out. What's going to be left if you factor out x minus 1? 4x plus 7 minus 2. So therefore, you got x minus 1, 4x plus 5, so your two answers are going to be 1 and negative 5/4, right? Same thing. There's a reason why I put these problems on here, because, like, are you doing the good thing or are you doing the bad thing? Okay, now D is just grind out algebra. Do I need to do D? Grind out the algebra. See, what you gotta do in problem D, what the heck, just to get it on video. You gotta, in order to figure out the least common denominator, you gotta factor everything. X minus 1, x minus 4. Here's a surprise. I got this problem out of an Algebra 1 book. X plus 2, x minus 1. I did. I'll show you the book too, if you want me to. X minus 4, x plus 2. Did I factor that correctly? Of course, I'm the teacher. Okay, whenever you have fractions, multiply both sides by the least common denominator, which is x minus 1, x minus 4, x plus 2. Okay, and then what? What are you going to get over here? X plus 2 times x plus 2 plus x plus 4 times x minus 4 equals x plus 6 times x minus 1. That is why you multiply both sides by the least common denominator so that you don't have any fractions in the next step. What the heck? Let's finish it. Multiply out like a mad dog. Yeah. Cancel out x squared. X squared minus x. So this is on, what do we have on this side? Negative 12 plus 6 minus 6. So is this factorable? Yeah, that's why I'm factoring it. So you get x equal 3 or negative 2. Box that, that's the answer. Well, if you did all this work and you did that, minus 1. How come minus 1? That's the answer, Mr. Park. No, look at the original problem. You have fractions. The denominator can never be 0. Does one of these make one of the denominators 0? Yeah, so you cross that one out. Or you can do what they did last year. They look at the answer on the bottom, and what number is this? D. They go, oh, the answer's only 3, so I've got to cross this one out. And they don't even know why they're crossing it out. Well, they do know because it's not on the bottom. But that's not you, yeah? You guys will never do something like that. Just look at the bottom. Okay, we're doing E. Okay, we just talked about this. This is not a quadratic equation, but it has quadratic form. This power is double that power, and that's a constant. So you treat it like a quadratic. So how do you factor it? Instead of x and x, you put x squared and x squared. 3 and 2, minus plus. Did I do that correctly? So x squared is either equal to 3 or negative 2. So anyway, you should know that you're going to get 4 answers, right? A polynomial of degree 4 has 4 answers. Where did we learn that last year? When did you guys learn that a polynomial of degree 7 will have 7 solutions? Yeah, you guys learned it in every Algebra 2 book has it in it. What is this called? A polynomial equation of degree 7 will have 7 roots. This is called the Fundamental Theorem of... Okay, no. The Fundamental Theorem of... We're not doing anything till we get it. Mathy people. A polynomial equation of degree n will have exactly n roots. This is called the Fundamental Theorem of Takata. Top Algebra 2 student. You can rescind, you know. Mason.
Algebra 2.
Oh, you had it! It's algebra. It's called the Fundamental Theorem of Algebra, not Algebra 2. Go to your room. Hey, you almost had it. And you're making a funny. So what is x? If x squared equals 3, what is x? If x squared is 3, what is x? No. plus or minus root 3. If x squared equals negative 2, what is x? I'll give you a hint. Plus or minus. How about look at the bottom? I root 2. The square root of negative 1 is I. Okay, F. Good thing we don't have the quiz or something today, otherwise we'd be in a heap of trouble. Okay, now, how do you solve this one? Now, most algebra teachers will tell you, oh, when you have a radical, isolate it and then square both sides. How many people did that? Only 1, 2, 3 people did it. Okay, the rest of you did the good way then. Ma, what is that way?
I don't know.
Page? Just bypass page. Yamaguchi?
No, I did it
Square both.
yeah.
Oh, but you don't want to admit.
I was gonna
Silva.
You just factor it.
There you go! It has quadratic form. See, if you square both sides, what did your teacher teach you in Algebra 1 and 2? If you square both sides, you have to, rhymes with mech. You have to check your answers. Did you guys learn that? Yes or no? Whenever you square both sides of an equation, you have to check your answers. Why? Because Mr. Teskey said so.
This is the rule that algebra technique, if you're in one.
There's a rule now.
Well, isn't that because you're only dealing with.
Okay, no. I stopped this thing. Okay. Is negative 3 equal to 3? Yes or no?
No.
Who said yes? Somebody said yes. Is negative 3? No. But what happens when you square both sides? There, square both sides. Is 9 equal to 9? That's why you gotta check your answers. Okay, so yes, you can square both sides, but you gotta check. But watch this. Instead of doing that, why not do this? Because now it has quadratic form. This power is double that. Isn't this like 1/2 power? This power is double this power. That's a constant. That's like this. It has quadratic form. So now you can just factor it like a quadratic. So instead of x and x, how are you going to do it? Root x and root x minus 4 and plus 2. Did I do that correctly? Yes, I'm the teacher. So root x is either equal to 4 or negative 2, but you cross out that. How come? Because you cannot square root a number and get a negative number. You can't. Okay? So therefore, what number squared will give you 4? I mean, the square root of what number will give you 4? 16. And you don't need to check your answers. You know why? Because you didn't square both sides. You know what I'm talking about? You only have to check your answers when you square, well, when you raise both sides to an even power. Like if you were to raise both sides to the 4th power, you would have to check too. And then G is just practice your algebra. Am I doing it? Okay, what the heck? Let's just do it for the video camera. Okay, now, what happens when you have 2 or more radicals in your equation? Like, if you just have one radical, you isolate it, easy, and square both sides. But what if you have 2 or more radicals? What do? You put them both on the same side, you put them on opposite sides. What should you do? Come on, what did you gotta learn something in algebra. Put the 2 radicals together, or put them on opposite sides like this. Somebody must have done it.
Kept them opposite. And you solve for the nicer one. And then it came.
Okay.
So that's what I did. But
Okay.
it's probably better.
So just square both sides now then, you're saying?
Yeah, that's what I did.
Okay. I agree. You should put the radicals on opposite sides and then square. Okay, I'll do the left side. Square this. 2x plus 5. I'll do that. Okay, who's doing the right side? Hano! Square the right side.
4 times. Oh wait,
Just read it off your paper.
I didn't get it. Oh wait, I can do this. 8.
You gotta play the game. Like pretend you wrote it on your paper or something. Make some paper crinkling or something. Look down at it or something.
8x
8x.
plus 4 radical 2x plus 1.
Okay, good. That's how you square. You gotta square the whole thing now. You know, last year I called on somebody. They just square that one plus that one. Where's the middle term? What middle term? Okay, now look, I still have a radical, so what do? It rhymes with isolate. You isolate the radical, because there's only one radical now. Bring everything on the left. So if you bring everything on the left, that's going to be 4 minus 6x. Did I do that correctly? Yes, I'm the teacher. And then now what? Square both sides again. Right now, square both sides. No. What should I do before I square both sides? It rhymes with reduce. Reduce! Look, you can divide by 2. Why is it good to reduce? Because it makes the numbers, it rhymes with smaller. Smaller. And if the numbers are smaller, there's a less chance of making errors. Because you guys know how you guys are with double digits, right? You guys can handle single digits right now. Now square both sides. 4 minus 12. Just tell me if I'm doing this correctly. Equal 8x. Did I do that correctly? Just say yes, I'm the teacher. Why would I write something wrong? 9x squared minus 20x plus 4. Is this factorable or do I have to use quadratic formula? Wait, let me look at the answers on the bottom, then I'll tell you. Should I go 9x and x or 3x and 3x? Wait, let me look at the answers on the bottom. You know, that's a good technique, you know. Is it 3x and 3x or 9x and 1x? Well, what are the answers to this problem? Where's G? Oh, I see 2 9s, so it must be 9x and x. You guys ever do that sometimes? Look at the answers to help you get the whatever. And is it 2 and 2 or 4 and 1? 2 and 2. Well, duh. If one of the answers is 2 9s, doesn't 9x minus 2 have to be one of the factors? So that it's kind of cheating. So x equals 2 9s or 2. Box that. That's the answer. No, because Mr. Park on the bottom it only says. What problem is this? It only says 2 9s, so gotta cross this out. Why do I cross that out? Because you squared both sides. Whenever you square both sides of an equation, you gotta check. When you plug in 2, try it. Here, let's try it. Plug in 2 here. What do you get? You get 3 equals plug in 2. 5. Is that true? Wait, let me get my calculator. No, it's not true. That's why you cross it out. And then if you plug in 2 9s, it comes out true. But see, a lot of you are just copying down now, right? You're not getting the practice of checking. Just for that, the probability of this being on tomorrow's quiz just went up to 0.9. Except when I have 3 radicals, just for that. But now that I told you that, I'm going to have 4. Now that I told you that, I'm going to go back to 1. But now since I told you that, I'm going to have 2. Whenever you square both sides, you have to check your answers. It's only going to be a 1-point thing though. Yeah, but the thing is, it's going to be 1 point if you leave off, if you don't cross out one of them. But see, sometimes there's no solution. Sometimes you have to cross out 2. Then that would be a minus 2. You know what I'm talking about? So you always got to check. Okay, we got to keep going. Oh man, we might not even have a lecture today. Okay, number 7, thank you. Number 8. Oh, number 8 and 9. Okay, number 8. Wait a minute, okay. Yes or no? In the examples, did you guys look at the examples? Wasn't there a problem where I showed you how to do this? Yes or no? Mason, redeem yourself with an fundamental theorem of algebra 2.
Yeah.
You're not even looking at the examples.
I did it, so.
But that doesn't, my question was, is there an example in the notes that shows you how to do this problem? Hey, x squared, just for that, the probability of this problem being on tomorrow's quiz is 0.9. Okay, it says, find the 5 smallest values of a, because a is a positive integer, so that this thing can be factored. Now, how do you determine if something is factorable? If something is factorable, that means what kind of roots does it have? Like here, see, it's factorable. What kind of roots did it have? Rhymes with national. Rational. And how do you determine if a quadratic equation has rational roots? We talked about this yesterday. The discriminant must be People, if you just look at the notes at that problem, it tells you everything. The discriminant must be a perfect square. So what is the discriminant? Okay, this is b. b squared minus 4ac has to be a perfect square. So if you simplify this, what is that? 24a plus 1 gotta equal a perfect square. Now I want to know what are the 5 smallest positive integers that work. Well, what's the smallest positive integer?
1.
Rhymes with bun. 1. If I plug in 1 for a, does that come out to a perfect square? Is 25 a perfect square? Wait, let me get my calculator. 1. What about 2? 48 plus 1 is 49. Yes! 3. 72 plus 1. 73 a perfect square? We really, I see people thinking. Oh my goodness. Okay, what about 4? 97. Is 97 a perfect square? Okay, good. That one you got kind of fast. 5. 121. Perfect square. And then you just keep on plugging in numbers until you get the first 5. So what are you guys going to do? Look at the bottom. Let's see. What does the bottom say? 1, 2, 5, 7, 12. I just will copy down 7 and 12, Mr. Park. Yeah. Cool. You just pay for it tomorrow. You guys gotta, you know, some of your arithmetic skills are just abysmal. This is where you practice them. Okay, B. Find the 3 smallest values of A that are greater than 100. Now you can use a calculator. Aha! You can use a calculator. So what do? How do you check this? Find the, just for that, this problem, you know what? 8B, the probability is 1. It's going to be on tomorrow's quiz. No, I can't say 1, 0.99. Because I can always change it at the last minute. So you get to use a calculator. Find the 3 smallest values of A that are greater than 100. So what's the first number you plug in? 101. So plug in 101 here. How do I check to see if it's a perfect square? You square root it, right? You square root it, and if it's a whole number, it's a perfect square, but it's not. So then you try 102. Then you try 103, 104, 105, 106. And you just keep on going. And if I look at the bottom, what's the first? 117. So when you hit 117, it worked. Mr. Park, that takes a long time. Yeah, that's why in the notes I showed you a better way to do it. And what is that way, Takata?
Put it into the Y.
Yeah, make a table. Okay, then I'm not going to show you how to do it, just for that. You guys are not even looking at the notes I spent half my career making. So instead of just plugging it one by one, you make a table. Just for that, the probability is 1, because I want to see you guys doing it tomorrow. I'm not going to teach you how. You guys read the notes. I'm just going to give you the premise of this thing. So basically, what you do is, like if you're in a TI, you go y1 equals c, because what you want the calculator to just do this quickly and show the results in a table. So what are you doing? You're plugging numbers into this, and then you're square rooting it. So your function is going to be the square root of 24x plus 1. Except I'm using x instead of a. You want your calculator to just plug in numbers very quickly into this. 101, 102, 103, 104, 105. Really fast. And then you want to see where does the result come out to a whole number, right? And then show the results in a table. Okay? So what's going to happen, whether you have a TI or a Casio, it doesn't matter. You're going to make a table. The first number you start plugging in is 101, because it says greater than 100, right? Then 100, and then you want to go by ones. You guys better read it. So what you do is you make the table and you keep scrolling down. You scroll down. And what are we looking for? See, what happens is your calculator is plugging this number into this. Spits out an answer. Spit, 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 spit. Keep scrolling down. What are we looking for? When this is a whole number. So the first time that you see a whole number here will be when this is 117. And then you keep scrolling down. The next time it's a whole number, it will be 126 and then 145. That's how you make the table. Very useful. So tomorrow, see what I do when I make my quizzes, I pretty much give you the same problem and just change the number. So, like what if I change that number from a 1 to a 2 and that to a 7 or something? Could you do it? And then what if I said, instead of greater than 100, what if I said greater than 500? Yeah, then start from 500 to 1. start at 501. But you have to tell a calculator that. So you guys better read that. And then finally, number 9, I will do one of them. Which one? I'll do either A or B. Pick one. Okay, I'll do A. Write a quadratic equation where these are the roots. So this is kind of going backwards. I'm going to give you the roots. You give me the equation. Now, a lot of people, you know what they do? They just do the quadratic formula backwards. And that works. It works. But then when the numbers get ugly, it takes a longer time. So there's a better way. How many roots does a quadratic equation have? It rhymes with move. There's 2. And what did we learn yesterday? If you add the 2 roots of a quadratic equation, you will always get negative b over a. If you multiply the 2 roots of a quadratic equation, you will always get c over a. Let's use that right now. Okay, here are the 2 roots. Add them together. Go. What is this plus this? I'll give you a hint. The root 5's cancel out. We cannot even add 2 fractions together. What is 2/3 plus 2/3? 4/3. Oh my gosh. If we cannot add, you're in trouble. You're just in trouble. Multiply the 2 roots together. Multiply them. How do you multiply fractions? Multiply the top. 4 minus 5. Which is -1. Multiply the bottom. What is 3 times 3? 9. We cannot even multiply. Maybe you guys better do the other way then. And then, now pick values for A, B, and C. What would be a good number since A shows up in both of them? What's a good number to call A? 3 or 9? 9. Use the least common denominator. Now, if A is 9, what does that make B? What? -12. And if A was 9, what is C? Look, if A is 9, what has to go on top here to make the 2 things equal? -1. Therefore, the quadratic equation is 9x squared minus 12x minus 1 equals 0. That's the good way of doing it. Now let me show you a gooder way. This is the math team secret. Did anybody use the math team secret? Takara, Mason, what is the math team secret?
You make it equal to x, and then you're gonna multiply the bottom.
Okay, there you go. How did you figure that on your own? Or you got it from another math team guy?
You have to do it. It's
Oh, yeah, see, math team training. Okay. Watch this. Look up. This is gonna bring tears to your eyes. You guys got Kleenex or something? Watch this. So you start with this. Now, this does not leave the room now. You have friends at Punahou or McKinley. You cannot tell them. This is a math team secret. Watch what I do. Multiply both sides by 3 and subtract 2. Okay, I'm just going to do it all in one step. What did I just do? I isolated the radical. Now square both sides. 9x squared minus 12x plus 4 is equal to 5. Move the 5 on this side. Boom, that's the answer. Bring the 5 on this side. 9x squared minus 12x minus 1 equals 0. Douche! Yeah! Isn't that neat? Why does that work? Well, go backwards. Look what happens. Oh, I hurt my hamstring. What? I should have wrote it down here. Look, what am I doing if you go backwards like this? What is this called? It's called completing the square. So you're just like completing the square going backwards. Math team secret. Okay, congratulations. We have 3 minutes for a lecture. Oh, the cycle is starting. And then tomorrow we have a quiz. It's supposed to be like a 10-minute quiz, but probably you guys can turn it into a 20-minute debacle. Yeah. There'll be 5 problems. You're going to use your graphing calculator on at least 1 problem. Which one? The one I showed you where you're going to make the table, or the one best fit straight line? Well, you don't know. Could be both. At least one of them could be both. Okay, we got now 2 minutes for our lecture. Thank you for interrupting. Okay, what are we doing today? Graphing parabolas. Okay, how am I going to even fit this in? Oh gosh, I'll just try. Okay, quickly, graph this. 2x squared minus 8x plus 5. What's the fastest way? No, you know what? I'm gonna put a negative. Yeah, whatever. What's the fastest way to graph a parabola? What's the most important part of the parabola? It rhymes with vertex. The vertex. And what did we learn last year? The x-coordinate of the vertex is negative b over 2a. Does that sound familiar? So this is a, b, and c. What is negative b over 2a? What's negative b over 2a? 2. So we know the x-coordinate of the vertex is 2. How do I find the y-coordinate? You plug it in. If you plug it in, you get 8 minus 16 plus 5. I'm sorry, one of them is the double-digit number, but you still got a handle. Negative 3, that's the vertex. Okay, so 2, negative 3, watch this. That's the vertex. Which way does it open? Up or down? How do you tell? You look at the leading coefficient. If it's positive up, negative down. So it's going to open up, so just go like this. That's not good enough. You got to be accurate. So, quickly, what is the y-intercept of this graph? Yeah, just look at that number there. So 5. 1, 2, 3, 4, 5. And then, since a parabola has symmetry, if you go 2 this way and then you got to go up there, if you go 2 that way, you got to be up there, and then that's the fastest way to graph a parabola. Okay, now, what form of a parabola is this? This is the most important thing for tonight's homework, right here. This form. What is this called? Vertex form. That's because the vertex of the parabola is. So in your problems tonight, most of the problems is I'm going to describe a parabola. You have to write the equation of it. Okay, so let's hopefully we can do this in 1 minute. 2, 5, that's the vertex. And here is the point 0, 4. Write the equation of this parabola. Anytime you know the coordinates of the vertex, you're in trouble. Here, start with this. What is the vertex? 2, 5. So x minus 2 squared plus 5. How do I figure out a? You plug in that point. You're going to be doing that multiple times tonight. So tomorrow I'm going to have just super plenty problems on the board. People! If you cannot do problems, come in the morning. Why do you think I come here at 6:30? And at lunch. Do I eat lunch with other teachers? No, I hate talking to adults. I'm in my room. All you gotta do is come in for help. Why do you think I became a teacher? I don't want to talk with people. Well, adults. I'm in my room all day long waiting for people to come in for help. But nobody comes. Bye.